So let's review the trick that I gave you for the Wittig, and I'll also do one for the imines, enamines, and the reaction with the aldols as well. So we're gonna basically do a little video on some of the different tricks. So for the Wittig reaction, our little trick to that is you would take your carbonyl. So the first part of the trick would be to erase the oxygen, and then the second step is to take your Wittig reagent, and it can come in two flavors depending on whether you draw the resonance or not. So if I draw the Wittig reagent without the resonance, or I draw it with the resonance, you're essentially going to take that carbon attached to the phosphorus. So take, the carbons attached to phosphorus, and then our third step is to join. And actually, let me put another carbon here so it's a little bit more complicated. So we're going to join that to where you replace the oxygen or remove the oxygen. So if I take this structure, I have 1, 2, 3 coming off of here. So carbon, the top of the double bond is carbon 1, and then 2, and then the 2 methyls would be the ones attached like that. Okay, so we can go backwards. If I were to give you something like this, I can go backwards, and I can go backwards in two different ways. I can snip the structure in that fashion and then add an oxygen back on the original double bond, and then where I'm snipping it, this carbon right here will give me 2 carbons, so I need to have 2 carbons on my Wittig reagent. Or I could have snipped this structure in the other way, so up here where this part becomes my double bond with my oxygen, so I add my oxygen back, and then the other part becomes my Wittig reagent. Okay, so when I did that, I'm just going to do the top one again. I'm going to snip this apart, snip apart, separate them from each other, add the oxygen back onto the double bond, and then on one of those carbons attach your triphenyl phosphine group and make that carbon a negative charge. So let's do another example of figuring out the products. So here I have this structure, and let's say for my Wittig reagent I'm adding something like this. So I have 1, 2, 3, 4, 5 carbons. On carbon 2 is a methyl, or carbon 3 is a methyl. So I'm going to take my oxygen, I'm going to erase it, add my carbon 1, 2, 3, 4. So 1, 2, 3, 4, 5. On carbon 2 is a methyl. On carbon 3 is also methyl. Okay. All right, let's do one for an imine. And so for an imine, you have a primary amine or ammonia. So you have to have at least 2 hydrogens on here. All right, so for this, basically erase the oxygen. Erase the oxygen, put your nitrogen back, and without the hydrogen. So if you have a primary amine or ammonia, that's how we do that. Let's say you had a secondary amine. With the secondary amine, you only have 1 hydrogen on here and 2 carbon groups, so we can't do that same trick, but you basically are going to erase your oxygen and then imagine this is not a mechanism. I'm going to say not mechanism. Don't treat it like a mechanism. You're essentially going to get rid of one of your bonds and move it to your more, I'm going to actually put this like that, move it to the more substituted side if there is one, and then you're going to put your nitrogen in that place. Okay. And then let's do one for the aldol condensation reaction. So for aldol condensation reactions, you're going to have a alpha beta unsaturated carbonyl. So the trick to that is on the side where the carbonyl is, you're going to split this apart where the carbon goes with the carbonyl. So this carbon right here stays there, and this side gets split apart, and then you add an oxygen to it. So that's the aldol trick, the imine trick, the enamine trick, and the Wittig trick.